Hello, 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 and welcome to this episode of the Julia Dispatch podcast. I am Chris Rackauckas,
I'm Stefan Kastanov.
and what we're going to talk about today is this month in the Julia world. And when I say this month, I actually mean this month's because I think that we've all been a little bit busy around here, and so the last post of the This Month in Julia podcast actually was multiple months. But it's all right because we also didn't record one last month, so it works out absolutely perfectly. So I'm going to pull this up here, but I think that the main thing that everyone starts with on this, and the big topic of what has just happened, is JuliaCon. So you want to give me your rundown of your idea of JuliaCon, and I'll add some thoughts to it as well.
Well, my version is that it's really grassroots, and it's about anything between 500 to 1,000 participants once a year, usually physically somewhere, except during the pandemic. And it's better than your typical academic conference. When you go to a physics conference, it is difficult to keep your focus. But at JuliaCon, everyone is really excited about the tools they've created, and everyone wants to be very helpful in making them easy for others to use. So the pedagogical quality of the talks is way higher than usual.
Yeah, I know that in a lot of academic talks, right, people are trying to show that they're smarter than each other, like my paper should be accepted and not yours, and that kind of thing. But it's a very different kind of thing when it's like, in this open source software community, it's like, oh, I want to use your software and you should use mine too, right? Like, so it's a very different. It's, instead of being antagonistic, it's like, how do we work together, type of environment. And I think that JuliaCon as a thing has generally worked out. Like, been my favorite conference for like 10 years. So it's it's got that vibe to it.
Yeah, I guess it kind of also is a good plug for how interoperable Julia is in general. You really see how a lot of technical problems become social organizational problems that you can solve by having people talk to each other, thanks to features like multiple dispatch and so on.
Yeah, and I one thing that I think I'll mention about this year that was kind of interesting was, there were a bit less. It wasn't the Julia Con that had the most people, but that of course had to do with certain things going on geopolitically worldwide. I had to take over 3 or 4 talks, I think, for different people because of different visa issues that hadn't happened before. So one of the things that will be actually interesting about this is that a lot of people I know have mentioned that they will be going to the JuliaCon Local in Europe, right? So I think that one of the things I see from this is that JuliaCon Local is going to be probably as big as a JuliaCon Global, and I don't know if the organizers are so prepared for that. I know that Guillaume had planned for it to be a local, but it just means that there's going to be 2 JuliaCons going now. Probably that's going to probably be a thing going forward, and and both are going to be of this like 500s of size, and maybe there'll be a third kicking off if some under the scenes things I'm hearing on different JuliaCons. So I think that the growth is now happening in the way of like, oh, we can't all fit in one spot, but that's okay, and so let's have multiple events. And I think that that's a pretty big thing for the community to be doing.
And there is a call out to registrations are still open for the JuliaCon in Paris. So anyone who has reasonably easy time getting there, make sure to get your registration.
Oh yeah, I hear that the karaoke is going to be great. So yeah, I think with the start of this month in Julia podcast, you highlighted a lot of things that were going on in Julia by highlighting a lot of the talks at JuliaCon, right? Are there any that you want to start with or kind of go through as like, oh, these are kind of highlights of very interesting things that have been happening in the community?
So, unlike usually with the newsletter, I didn't include much in terms of highlights from the ecosystem. There were a lot of good talks about scientific software or not scientific software in many different domains. The sparse arrays talks were amazing. As a whole, generally just everyone that's interested in the ecosystem should check the list of talks and just look up the recordings for those. Here, this list is really more focused on the Julia language, compiler, the type system, and the more higher level, all-encompassing ecosystem questions about continuous integration and so on. So I guess we can start with the state of Julia. That one is always done at JuliaCon. It's the first one in the list, and it's a good overview for anyone that just wants to enjoy a 30-minute talk that goes rapid through the recent developments. I enjoyed the joke that State of Julia is meant to be slide deck karaoke for the developers, as it's put together last minute by about 15 to 20 core developers, and then just on the spot the presenters need to be able to discuss what's happening.
Yeah, I was there actually in the presentation because some of the co-creators and core contributors were actually my roommates during this JuliaCon, right? It's a fun JuliaCon because we were all in the pit housing, right? So we got to act like we're grad students again for a little bit. And yeah, so the way that the state of Julia was put together this year was 20 folks who are all different core contributors were putting in slides about their core contributions to the compiler, and then you have to have one compiler engineer go in front of the stage and be like, "Oh yeah, here's everything that happened. I know all this, right?" So it was but like, and then there was a lot of a lot of AI graphics that were created this time to throw off the presentation. So there's some fun stuff in there, especially how the sausage is made. That was a give me a photorealistic how the sausage is made kind of gif in there. So there's some Easter eggs and everything. It's a fun talk, and it also goes into a lot about where Julie is and where to expect to go in the future. So I think it's a definitely a good one to start with. I think some of the ones that I like the most, Cody. If I think a lot of people might not have known Cody before. Cody's someone who I work very closely with because he's working with the Dyad team in terms of a lot of the compilation tooling, and he's also this core compiler developer who's been working a lot on trim and making it so that way we can get binaries into the hands of real devices and such. And so Cody had some really nice talks, I think, that come from this perspective of he's been a compiler engineer in other communities before, and now he's kind of looking at Julia with with this kind of perspective, and some of these ideas around what we do about invalidations and extended types, and what are things we could do to the type system to improve the way that we compile and such. I think he has a lot of really nice, fresh ideas. So it might be a name that Cody Tapscott might be a name that a lot of people don't click right away to. They go to the Jeff Bezosons and stuff. But if you haven't seen what Cody's been up to and what he's saying, really check it out. I think that he has some really interesting ideas that will shape a lot of the compiler in the near future.
And that's Tupularity on GitHub and Slack,
Yep.
right?
Yep.
Those two talks of his were one of my favorites. I guess other things in terms of the more static thought of what you can do with Julia, I enjoyed the discussion of the old and new language servers. Those are the second and third bullet points.
Yep.
So, for context, the language server is a protocol that VS Code has established, but now it's used by many other editors as a standard way to have some static analysis tool, give you extra information in your IDE. The ones that we have in the Julia plugin for VS Code are a little bit ad hoc. That's the talk about the current, the past, present, and future of the Julia language server. They work pretty well, but they don't actually tap into the internals of Julia. Rather, they re-implement a bunch of internals, and as such, they cannot be as high fidelity as really the knowledge that the compiler directly has. Claire has been working for quite a while on creating Julia syntax and Julia lowering, which are nice ways to actually, for a user level, to peek into those internals, to re-implement some of those internals, and to now provide some of those internals for introspection. So there is a new language server being built that's employing these tools created by Claire, and also the Jet Static Analyzer. So soon enough, Julia would really feel like static language, a statically typed language with all its guarantees, although it's incredibly dynamic.
Yeah, yeah, and I think that kind of is, working well with trim and everything, right? Because as you start to want to use trimming and building small binaries, there's more guarantees you want to have in terms of staticness, and so these two changes are coming a lot on the same way. And I think that there's some ecosystem overhaul that has to go with this. I've been working in the last week here since JuliaCon and learning about some of these changes on changes to Julia formatter, right? So Julia formatter, for example, used to also have its own ad hoc way of parsing and everything. But now that Julia syntax exists, Julia formatter got a version 2 that uses the Julia syntax. So it just uses the same parser as Julia, which is great because your formatter should know the language the same way that the language knows itself, right? But that means that your syntax, your style guides and everything have to all be rewritten to the Julia to that. So there will be definitely some overhaul, but I think the overhaul is good, right? A lot of things in terms of Cthulhu, in terms of revise, all these kind of like, the language server, the linting that we have inside of VS Code, all of those are going to have to be redone on top of Julia lowering, but it'll be a lot more correct. And so that's just a major win. Um, I think one of the other things I want to highlight in here is that reactant. Definitely, this is one of my students, so I'm a bit biased here. But when he's able to show, for example, Billy and Avik, when they show that, you take you take a ocean simulator like Oceananigans that was written, it was written to be fast, Julia, for one computer, and it automatically recompiles it so that way it works on 4,096 GPUs, right? Like that's more than just a party trick at that point. Like it's like, okay, now we do HPC for free, right? Which is, I think that's really bringing Julia to a whole nother level, right? Like that kind of level of, we now run on thousands of GPUs. That was something that was pretty manual before, but now it's like, I think you can easily say that Julia is probably the easiest language to do that with now because of the reactant stack. So, if people haven't seen it, it's definitely I would tell everyone to just keep on watching reactant as like the new thing that's like going to change a lot of workflows.
I really enjoyed the whole family of talks, not just about reactant, but about the whole notion of making it easy to write code that semantically reads pleasantly, logically, and automate the deployment on heterogeneous HPC systems. So in
Hmm.
that
Hmm.
sense, the three bullet points you've selected, Dagger, which is uh, reasonably classically styled way of writing linear algebra in a semantically pleasant way, and then behind the scenes, it automatically takes care of distribution on GPUs or just MPI multi node systems, accelerated kernels, which is very complementary to it, and it's pleasant to see how they uh, interact with each other, how they cross pollinate, how you use how there are abstractions that are built in one or the other, and then they're being shared. There's a lot of code now that is reused between the two tools, and React that has a little bit of a different taste in my mind.
It does. It does.
It's much more hardcore compiler theory, really this magical sufficiently smart compiler that
Hmm.
just you need to do way less of the uh, defensiveness in the way you program. You don't need to be very explicit in using only these permitted pieces of linear algebra semantics. Reactant just seems to be able to work with much more general piece of code.
Hmm. Hmm. I mean, it is using the same linear algebra pieces, right? It's just helping find it for you, right? If you wrote out a loop that was the matrix multiplication, it would do things like try to identify that it is a matrix multiplication, turn it into one at the XLA and MLIR level, and then use these multi-threaded GPU or whatnot calls to matrix multiplication. So it's a very different kind of tool in that sense, right? I do think that one of the nice things that's going on in like the Dagger space was there was a really nice BOF in the discussion going on. about how could we make use of Dagger as a not just a way to parallelize, but also a way to kind of formulate code, right? And there are multiple people, me included, that was expressing things like, could we set up code with Dagger so that way we can, say, hey, here are the independent tasks, and if I use it with Dagger, then I have the dependencies and it runs in parallel. But I can also just set up my code as independent tasks and have it, run in serial, and so I could just always tell Julia, hey, here's the structure of my stuff. It can be parallel, and then we can have all these kinds of parallel libraries just do things to this knowledge, right? And I think so. I think that going forward, there's probably going to be some stuff going on in terms of like hey, you just tell me what things can run what things can run in parallel or asynchronously. Tell me which things cannot, and there'll be multiple backends that'll be able to in multiple packages that'll be able to act on the same piece of code to do that parallelism, right? Kind of like how what's going on with accelerated kernels and kernel abstractions and Reactant is in, doing these different pieces. I think that you'll be able to write single pieces of code and have many different parallel engines work on it, and that'll be a very interesting space to be working in.
And to me, it's just mind blowing that these very independent efforts seem to be uh, pretty interoperable. It's not for
Yeah.
free, but it's
Mhm.
amazing that completely different pieces of technology developed by different folks independently are uh, successfully working together.
Yeah, I think one of the things that I didn't actually get to see the talk, but I know quite a bit about this just because I've been asking Stefan for this for about a year now, so I think I could say I'm the muse behind this talk in some sense. We've had a lot of issues with downgrade CI and the ability to be able to test how minimum versions are done, right? And so Stefan was like, "Oh, I've been meaning to work on a problem on something that will solve this and other problems." And it came back with the new SAP based a resolver for PKG. So it actually solves a full SAT problem in order to get you like a very clean resolving result. The resolver from before had more had like a heuristic solution and whatnot, but instead you could just say, okay, well here's the actual mathematical problem I'm trying to solve. It's NP hard. The heuristic solution is one greedy algorithm through it, but I have now a whole SAT based resolver. So if I solve the three SAT problem, I can give you very good version resolution. And so now we've already been starting to deploy that in terms of the downgrade CI. We got a version 2 that then is able to be able to say like, okay, move simulate the case where someone has a very old package and you move everything to minimum versions. Are the minimum versions okay, right? So we have these kind of CI tests that can do this stuff automatically, and it's all being built from this new resolver.jl. So I think it's a really cool system, and I know a lot about it. I assume the talk came out pretty well because
It
of
was
what it
great.
is.
Actually, that's a good segue into the state of continuous integration in the SIMO ecosystem. It's a talk that I've had a little bit higher
Mhm,
up from someone in your team. This was very informative talk for me that
mhm,
described in great detail a lot of the difficulties of scalable management of a large GitHub organization and how to just use the tools available to you to remove redundancies and repetitions in just the configuration of CI
mhm, mhm.
and just the reliability of the testing platform behind a GitHub organization. So that was great for anyone who needs to deal with more than a couple of repositories.
Yeah, yeah. Adant has done an amazing job in setting up SciML, so that way, yeah. I mean, I think we're almost at 200 registered Julia packages, and so yeah, when something happens in the ecosystem, like there's some dependency you need to knock out, or there's you need to bump to the new LTS or something, right? This is something where it could be someone making 200 pull requests and merging them, right? And so instead, we had to find out solutions, and so Adant has really been the one who came up with a lot of these solutions in terms of having like a centralized management system where it can, make a change to one file and it changes all of the CI files throughout the organization. And so I know that Ananta gave a talk that kind of went through how this all works, and it's definitely I don't see any other group in the Julia Lang space using this kind of stuff yet. So I think this is a nice talk to start proliferating some of the tools and ideas that he's built out.
Julia Dynamics has been interesting in stuff like that, so I'm imagining they will soon enough be incorporating that same system.
Were there any others that you wanted to highlight from the list here? And
No, I think we can jump. Actually, one thing. Going off from Dagger, there were a number of interesting talks related to multi-threading, but not the performance side of multi-threading, rather the reliability and management side of multi-threading. So the lead follow or get out of the way, Julia and Thread Python by Katie. This was a great talk on clarifying the difficulties of having multi-threaded Python and Julia work together. And Cancellation, aka the big red button, by the creator of Dagger as well, is a great talk that describes why is it so difficult to have reliable cancellation in a in a in a general purpose language like Julia or C or any of the .NET languages. And it kind of alludes to why it happens to be relatively easy in Python, a feature that is special to Python because of how its interpreter works and how it has a lot of locking built into that interpreter. But with that,
yeah, that was one that I had to miss because I think that one of Cody's are at the same time or something. Like this is why everyone wants to start splitting JuliaCon because everyone's like, oh, I can't see all the talks.
Yeah, after a day at JuliaCon, I usually spend a few hours in the evening actually listening through all the talks that I've missed. Should we jump through the main part of the newsletter?
Yeah, so let's head on to the internals, the for and core repos. So just as that module refers to enclosing the module object, the internal variable var of self can be used to refer to the enclosing function object. Oh, I did not know that. Yeah, okay, so you could do var of self to refer to the function itself that is in there. That is that even documented?
No. But this PR that's linked there makes it an actual proper document feature. So the way you have at module referring to the current module, at file returning to the current file. For instance, if you want to have a pretty debug message that points out to exactly where something happened, at function is a cute way to in a macro, for instance, to write self-referential recursive code without having to know a priori what's the name of the function.
Yeah, okay. I mean, it just, it seems like it fits. Yeah. Now that it's mentioned, I just go, okay, we should have had that a while ago. It just sounds like it should have always been there. Yeah, so that's a very nice contribution from Miles Cranmer, right? The guy who does a lot of the symbolic regression tooling.
So no surprise that he's the one contributing it, given that he has to work with generating functions on the fly all the time.
And there's a competition to create a faster sum and potentially have it in base. Oh, this is a very Julia activity.
Yep. This comes really from Matt Bauman. He has been working a lot on various reduce-related functions in core Julia, doing an enormous amount of work on fixing minor edge case bugs or just ensuring consistency in performance, figuring out that certain modern architectures actually don't need the fallbacks that have been implemented that presumably would be faster or slower or whatever. But anyway, there's an enormous amount of work on improving any reduce related function in Julia, and this is a small part of that story.
Does anyone have a summary in here on what the final, this is the speed up versus the current base or
no, I don't think I have one.
Which means y'all got to read this whole thread called Performance Challenged. Can you write a faster sum?
And just by seeing the names of the posters, you know that there will be a lot of nitty gritty details about how to write fast inner loop codes, no matter the language.
Yeah, so Matt Bauman, who's been the guy who created a lot of Julia's core array system, Mason Broder, who's now at Neuroblocks, but who works on things like transducers and the static compiler.jl, right? You have Chris Elrod, who built out the loop vectorization and that whole performance stack. You got Gabriel Beraldi, who's one of the core compiler engineers, and you got Steven Johnson, who's one of the people he's the guy who built FFTW, the fastest Fourier transform of the West, right? And so, yeah, you got all of them hacking together, and how do you just make some faster, which is a pretty interesting gathering of folks to be there. All right, about a year ago, there was a proposal for cleaner printing of repetitions and stack traces due to recursion. That proposal and implementation is now merged. Okay, this is the abbreviated stack traces.
This is related to it. This is
Okay.
for when you have, usually due to recursion breaking somewhere, a very long stack trace. It was already abbreviated, one form of abbreviated by marking repetitions instead of printing all the repetitions. This is a small quality of life improvement, but it's building upon a few others related to improving the stack traces. I know topic that you also have been pretty invested in.
Mhm.
So besides just prettier Unicode that marks where the stack trace is actually repeated, it also simplifies the code related to that printing, and hopefully will be helping with future work on prettifying the stack traces. Especially see this example of nested repetition, where you have one block that has been repeated, and that block as a whole has been repeated multiple times after that.
Mhm. Mhm.
I know it sounds a little bit nitty gritty, but it's an important little step into making the stack traces much more legible.
Yeah, yeah. Well, and I think that there's just so much we have to do on and I think the syntax is really nice. It's pretty immediately clear. That's like, okay, this set of two is repeated 10 times, and I think that this plus there's some stuff going on to potentially soon make forward diff stack traces a lot smaller as well, right? And then there's also certain things going on in terms of cutting out smaller types and making better use of printing with type aliases. So I do think that I don't think we're going to be at stack trace nirvana anytime soon, but I think that well, we could probably at least make our stack traces at least a quarter of the size of what they were without losing information, which is a pretty amazing kind of change.
And the rest of the bullet points are relatively minor, a little bit better documentation for the garbage collector, a lot of improvements on the compiler's understanding of effects when related to iteration. Those one by one might be interesting for people to look into, just if they want to learn more about how a compiler engineer thinks about effects and how they work on low-level improvements to the code. For
Yeah,
me, that has been informative as a way to learn these features of the programming language.
Yeah, I know that Oscar has been looking quite a bit into these, and I think that one of the things that will happen with this is you won't see anything immediate, like, right? I mean, but basically, as a compiler learns more and more about, like, okay, these are the bounds, and here's how I propagate bounds through this operation and such. Then downstream, it'll know the bounds better, and then you have another piece that says, oh, you can delete, this array allocation if you know that the arrays stay the same size. And finally, if the compiler gets enough information, it'll just start to completely delete allocations and loops, because it just goes, oh, I now know that these arrays are all the same size. I know that inside of a loop, if arrays are the same size and if used like this, then I don't need it anymore. And so therefore I can reuse that memory. And so each one of these little pieces are kind of, one kind of jab at making the compiler learn a little bit more, just so that way it can optimize a little bit more and keep a little bit more information. Yeah, so that's cool that there's a lot going on in that realm, because that was one of the promises of the new memory type, right? If the memory in Julia is built in, then the compiler can know more about how it's allocating, and it can do more to optimize it, and that seems to be coming into fruition. A new function gets added to get the nth element of iterable. I would have thought that take would have done this, right?
I think this is something along the lines of take nth. So
Mhm.
you can have arguments about whether this should be in base or not, but it was simple enough.
Mhm. Oh, I could see that the arguments are abound. All right. So this could be a fun read. And then I think we're getting down to the end where so in search of contributors and new maintainers. So it looks like there's a lot of groups that are looking for for different bounties and such. So Graph.jl has a few bounties on integrating external graph libraries.
Just I'm seeing still the previous window. Maybe. Oh, okay. I see it again.
Yeah, so it looks like Graph.jl has a few bounties for integrating with different graph libraries that were opened over the last few weeks. So if you want to integrate with iGraphs, Lemon, Very Naughty, NetworkX, right? So it looks like some C libraries. I believe NetworkX was a Python one, right?
Yep. Python, C, and C++.
Yeah, so if you want to integrate with the external world, if you're that kind of coding extrovert, looks like there's $400 each on these bounties if you're interested in helping out the ecosystem. So there's a lot going on there. Julia Package Comparisons is in search of a new maintainer. So if you want to write about comparing between packages, it looks like that needs someone to kind of step up in the space. So if that's your cup of tea, then there's a lot to drink. The Center for Quantum Networks is running bounties and mini grants on a bunch of quantum information science. I believe that would be you that would know a lot about this, right?
The NSF has been very supportive to the idea of growing the open source ecosystem, and through the Center for Quantum Networks, they have been helping with onboarding new contributors, and we do spend plenty of time hand-holding. So this doesn't need to be an experienced programmer or someone with a lot of knowledge in quantum information science. Just a lot of enthusiasm.
Yeah. Oh, I didn't know that quantum optics would be in this set. I mean, I remember actually in 2019 or so, I think I rewrote some of the internals of quantum optics. So I still know that one quite well because that one's built on ODE solver. So I'd be happy to help anyone else who wants to learn in that space. So yeah, quantum savory, quantum Clifford, quantum symbolics, quantum optics.
We're not very creative in the names.
Mm-hmm. Well, I mean, I also just slam SIMO in front of half of them. So I call it's not lack of creativity, it's name spacing.
Yeah.
So, and then the other one is SIMO. We're running a bunch of funded small projects. In fact, let me pull up here some of what has, so there's some projects that are still going, which, for example, adding a huge benchmark set of Qdis.jl to the optimization benchmarks. This should actually merge in the next week. So hopefully we'll get 300 optimizer benchmarks. We can then tell you, which BFGS is the best. I'll be able to point to things. There's lots of DAE problems that need benchmarks, refactoring to be done. And actually, I think that the loop vectorization update to version 1.12, that should actually finish in the next week or two here. So there's been a lot of successful projects that we've had. And I think that the loop vectorization one is one that a lot of people have been wondering or worrying about and such. So I think I just dropped a bit of news here that I think a lot of people, if you haven't been following the repo, might not have seen. But I do think that the small grants program that we've had has been pretty successful, right? I want to just highlight a blog post that we had out just a little bit ago, which was the program impact by the numbers. There's a lot of details on what exactly the different projects were and everything. But we ended up having 13 projects over the last year. 8 of them were successful. The 5 that weren't successful had other people come in, and so they're still currently active, right? So we just kind of continually had activity on these projects. I'd say 99 to 90% success rate. Now, the 96% success rate is not 90% of people who applied ended up, finishing a project, but it is, projects for which we've put up and someone started working on. We did get someone to complete it. I would say probably there's a success rate of the contributors by about 1/3. So you'd have someone come and they never show up with code, or you don't hear from them again, and then 1 month later you get someone else who's just like, oh, this is interesting. You get a third person in there. That third person does it all the way through, and it's like, okay, we're good. So that was kind of the norm. That was like most projects never had like a medium, and then it's like, oh, I can't finish this. Most of it's just either like they didn't show up again or they completed it, and it just took a few rounds to find someone who'd complete it. But yeah, so we paid out a total of 2,400 to 2,600. I think that's depending on whether the last payout was actually finished. And so, the SciML Small Grants Program, we're just going to keep on doing this because it brought in a lot of very young new contributors to the ecosystem who have stayed around and have actually, some of them, that was their first contribution. They went to get a job at Pumas AI or an internship and such. And so it really brought in a lot of new blood into the ecosystem. So I'm glad other groups are really starting to do a lot of this as well, because we had a lot of success over the last year here with that.
And for the academics listening, the NSF and other grant agencies are actually really happy to dedicate a few $1,000s per year and something like that. It's not something that is noticeable on their scale of their budgets. So putting it in a grant proposal does make the reviewers pleased.
Mm-hmm. That sounds great. Yeah, I mean, and if you need any help running such a program, we have a system now with IML that's doing it by the bulk, right? So if you want to just like jump into what we got going, we'd be definitely happy to. We'd be definitely happy to help you get going. Yeah, so I think with other things going on, one of the big things I think that happened at JuliaCon and in this time frame was there's a new front end to Julia, which is this diet. I'm wearing this right here, so corporate shout out. But it's a front end to Julia, so it's a modeling language. So you can think about it as a domain specific language with a lot of tooling built into VS Code, and of course lowers to Julia code that's running Julia solvers and all that. And I think one of the nice talks that I liked a lot at this JuliaCon was the keynote of one of the first keynote was he was the CTO of Ansys, now the senior VP of Synopsys, and he talked all about the role of Julia and Julia Hub and things within the the greater commercial simulation world in the coming future. So I just want to give a shout out to my sponsors here, about but if you're interested then in a lot of the how Julia is growing in like a commercial context, definitely check out that talk.
Other forum posts that might be of interest. I think the announcement of multiple inherent interfaces.gl is an interesting read. It's one more one more episode of a pretty long story about how to do traits or interfaces or both in Julia, and there are a few links to related posts on the topic from the past. I won't go into the details of this particular implementation, but the Julia type system is actually sufficiently rich to let you implement interfaces without having to have them supported by the base language, at least for some definition of that word. And it's just interesting from a programming language theory point of view to read through these topics.
Mm-hmm.
Kind of related, there is a separate discussion of tools for meta programming, discussing how macro tools and expression tools and ML style have evolved, and also a shout out to Expronicon and Moshi, which are more recent tools in that direction.
Mm-hmm. Mm-hmm. Yeah, we've been using a lot of, especially Moshi in these days. So I think a lot of people, if you don't know about some types and the tools for working with them to avoid multiple dispatch in cases that are dynamic and such, definitely take a look at all this. It's definitely been a growing space, I think, within the Julia world of of tooling. And speaking of growing space within the Julia world, I do want to give myself a shout out here, where I sat down and wrote for everyone exactly how we're starting to use Claude. So it was mentioned a few times at Julia Hub, because I was walking around with my phone. I have like all these Tmux instances running, right? That I got 32 AI bots running. So actually, I think about 6 or 7 pull requests were open during this the recording of this podcast, right? So the AI and the LLM tools are here. They're working with Julia. I do use a lot of Claude, and I described exactly how we're starting to make use of this throughout the SciML ecosystem. The general note is that they don't solve very hard problems, but they solve very easy problems, and you have a lot of easy problems, like fixing typos, reformatting your repos, making it so that way instead of you doing using package X, you explicitly say all the functions, right? If you ever wanted to be like, yeah, that's better style, that's a better way to write code, but it's too much time to set that up, right? these AI tools are actually a very good way to kind of improve your code. And even one of the things I did is I just said, sent in a lot of repos that said, find the easiest problem to solve and solve it, right? And it found some things like, oh, add a new keyword argument for verbosity that prints out this, right? If someone's giving you a very clear issue, it just goes and it does it. And you just go, hey, oh, that code looks correct, right? So I'll actually write a full blog post on this in more detail, and I'll want to turn this into a larger discussion. But if you want to kind of get the feel for how should you be using these LLM tools, and I say this as like how should you be using LLM tools as someone who's not like a there's a lot of people who are using them that don't know how to code and they're just vibe coding as a cowboy, and so whatnot. Like we're not talking about that. We're saying like if you're an expert, you've been coding for 10 years, and you know what you're doing. But you still hear about this AI stuff, and you're like, how can you actually use it if you know that they're sometimes incorrect? Well, hopefully this post goes into a lot of detail of a lot of cases to show you that they're still useful, and there's a lot of use cases you can come up with them. So just throwing a shout out there, and I'm probably going to write a blog post that summarizes a bit better in the near future here. But I think that if you're not using some of these tools yet, it's probably time for a lot of the Julia community to start giving them a try.
And for what's worth, the moment I saw that post from you, it's finally when I got subscription to Claude. So now I'm doing the same.
Oh, how many PRs or how much code how much coding have you been doing with these?
Not much yet. I actually am still struggling in setting up a good agents file, which is really what I see as the great value add of the post that you have. It really clarifies how you should instruct the LOM, the agent, to start helping you. So I'm still at that step, but hopefully in the next few weeks I'll start having some of those typo and reformatting style chores being taken care of.
Yeah, so I will say one thing I didn't mention inside of the inside of that post, but I think I'm obligated to mention because of some comments from folks in Julie Lake and such, is that don't put all this inside of your main don't put all of this inside of your main your main
Dev environment.
because if you put things on like unsafe, you could put things to allow what is it, dangerously skip permissions, right? Don't do that from your main account. But what a really nice thing that you want to do if you want to start trying these, and you just want to see what they can do. I can show you one of the things I set up here. Is I just set up a different GitHub account that's called just me Claude, right? So it's just me in a little robot costume, and it's made 100 contributions in the last week here already. And it has no write privileges, right? So it has, it's not allowed to merge anything. A human still has to check what it does, but it's able to say, take the linearsolve.jl package, add allocheck.jl, and then write all these tests for making sure that allocations are you have 0 allocations, and then it finds out which ones are failing the test and puts them in a different test group and such. So that way you then are set up to do a test-driven development for that. So all this kind of stuff that if you're scared of using them, you can sandbox them really nicely. Actually, a shout out to another tool. Ken Fisher has sandbox.jl, which is for setting up like a Docker sandbox, so that way you can just let the AI bots run loose on things, and it can be safe because it can no longer change your operating system, right? So there's a lot of this tooling going on, and I think that we should probably have a longer discussion just on this topic, but I'll not go too deep into it, I guess.
I guess one other things to mention, going back to the topic of interfaces and some types and so on, another approach to solving the problems of that some types solve, another approach to solving the issue of slow runtime dispatch over a diversely typed collection of instances is what game engines do all the time, because they would have a ton of different entities in their system. And there is actually a game engine being developed in Julia. The game engine on its own is definitely interesting, but for me what's more interesting is that with it comes an ECS framework, an entity component system framework, which is another a standard solution to the problem that some types and ADTs solve. So for those that are interested in that type of programming, that's yet another resource to look into.
Cool. I had not known about that. So yeah. So it looks like this is what the Rex is. I didn't know what that was for. So I think I'll definitely be diving into that myself. Yeah, and and speaking of games, one of our previous folks on the Julia Dispatch podcast is actually creating a commercial game with Julia. So we can, and I think he streams a lot of what he does. So if you want to watch the process on a live stream of going from Julia to a game that is on Steam, he is on the path. So you can he's blogging and sharing all the steps of it. So definitely this is a fun thing to be watching. So I think we're getting to the bottom here. The fixed size array stuff, if you haven't seen fixed size arrays yet, it's better. It's probably how Julia's base array should be. And I think that Mose and Oscar had a nice talk on it, right? I think ND arrays is actually data interpolations. ND is probably a little bit young right now to be. I'll give it like a month or two. Let's see. Many things to talk about an array interface, and yeah, but I think that this is kind of this is kind of it. Well, maybe a shout out, maybe a shout out discussion to a little bit of Mooncake. Mooncake is in particular a library that I've been seeing grow a lot within the last year here, and I've been kind of talking with people a lot publicly. And Simon will probably actually be defaulting to Mooncake a bit more in the near future because it's much smoother between different Julia versions. It's able to enzyme and such needs to differentiate the garbage collector, and that always takes a while to get robust for a new Julia version. Whereas Mooncake is higher level in Julia, but it still supports things like mutation. So I would kind of say that like Mooncake is Zygote but done good with with mutation support. Like that's my one liner to it, and I don't know if it reaches the entire goal right now, but I would say that maybe like in the next month or two, it's gotten pretty close now to being able to say like if it runs with Zygote, then it should run with Mooncake. I think it's gotten pretty close to that. I think with some of the folks I've been talking with at JuliaCon, they mentioned that Zygote still can do a bit better just because of a lot of the manual rules have been written in so many places for Zygote. But Mooncake as an autodiff engine is already better, and it's incorporating a lot more of these rules over time. So it's getting pretty close to being, I think, a nice new default to dethrone Zygote.
And with that, I think we're at the end of the letter.
Yeah, I think we're at the end. Anything else that you want to bring up?
No. Besides, well, if anyone wants to help with the letter, if there's anything that's missing from the letter, at the bottom of the newsletter, there's always a link for people to help. So feel free to join the writing there.
Yeah, and I guess if you're in the Copenhagen region and you want to talk about Julia and finite element methods, there's a FerriteCon happening on August 28th, and so sounds like it could be a lot of fun. So definitely check that out if you're in the area. Alrighty, I think we're about at the end here. So thank you everyone, and thank you for watching this episode. In our next episode, we will have. Who knows at this point? But you will know when it goes online. So we know that we missed a few like a month or so of uploads. We actually did record content through all this. We've just been slower on getting some of it done. So don't worry, we are here to stay. We're just gonna have a backlog of a bunch of extra episodes drop soon. So hopefully that will make everyone happy. So see y'all in the near future. Ta-ta for now.
Bye bye.